My name is Kainton Againius, and in a few minutes I'm going to explain to you what is support vector machines in machine learning. Before I start, I would like to mention that support vector machine is a classifier. Remember that we've discussed in Machine Learning 101. If you are following it, we know about the base classifier. We also know about the k-nearest neighbor classifier. Now support vector machine is another type of classifier. Now let's see how support vector machine works, and we are going to be looking at these terms. I want you to learn these terms at the end of this 5 minutes or thereabout lesson. So what is support vector machine? It is a numerical classifier. So always remember that support vector machine is a classifier. How does it work? It draws a single decision boundary and maximizes the margin between two classes of data. So as usual, we have different classes of data provided. So we have let's call it the blue class, and we also have the red class. So in this case, we are trying to draw a margin between them. So you can see this black line that has been drawn between the two classes. I have distance from here to the margin is maximum, and distance from here to the margin is maximum. Let's look at something that actually classifies, but it's not the margin is not maximum. So let me take this pen so that you can see that distance from here to here is not maximum. So in this case, this is not a good classifier. So you can see that this is a good one because we have the maximum distance between the points. And now we've drawn these two lines to indicate the point that is closest to the dividing line, right? Good. So let's review the terms. We have margin. Margin is the distance from the nearest data point to the dividing line, right? Okay. So margin width is also as well the distance between these two. Is distance between this point and this point. So basically, the margin width is 2 times the margin, right? Now let's talk about linear separability. I don't know if I have it in the next slide. Okay, so now I don't have it in the next slide, so I'm going to go back a bit. So linear separability has it that you might have data points that are not linearly separable. What it means is that you have data points that you cannot actually separate using a linear separator. Let's take, for instance, we have a red and a blue data point. We have this, we have this, we have this, and we have this. So, and we have another set of points. Sorry, let me take a blue line, a blue ink this time. So we have this, and we have this, and we have this, and we have this. So at this point, we cannot actually draw any line to divide the red and the blue data points. And in this case, we say that this data point or this data set is not linearly separable. So for you to use support vector machine to classify, the data set must be linearly separable. So you have this, it is linearly separable, but it doesn't give us a maximum margin classification. And here you have it's linearly separable and gives a maximum margin classification. Let's move to the next slide to see. So what are support vectors? Now you've seen support vector machine is a classifier. Now support vectors are points that determine the decision boundary. So let's see, in this case, in this one we have, this is a support vector and this is a support vector. So you have here, we have 2 support vectors. And now you have decision boundaries is at this point and at this point as well. In this case, we have 3 support vectors, 1, 2, 3. Take note that support vector, it's not this line that is parallel to the dividing line. It is not this line. It is actually the data points that are actually called support vectors. So here we have 3 support vectors, okay? So take this definition in mind. A hyperplane is a plane whose dimension is 1 less than the ambient plane. Let's forget about this jargon. Let's just say that if you have a 2-dimensional data plot, then a hyperplane will be a line that divides it. If you have a 3-dimensional space, let's say a cylinder, or a cube, the hyperplane will be a two-dimensional plane. That is, you can slice a cylinder into two in just 2 dimensions. So you have a flat space, and that is two-dimensional space becomes a hyperplane when you are considering three-dimensional data sets. All right. So how then do you determine the decision boundary? So let me quickly give an introduction to how this is done. I actually will cover it more in another class. So if you have an equation that says beta 0 plus beta 1x equal to 0, so this equation represents the classifier. So the classifier is represented by this equation. So we have at points, there are some points where beta 0 plus beta 1 x is greater than 0, and there are points where beta 0 plus beta 1 x is less than 0. So at this point, we have one of the classes, and at this point, we have the other class. So the theory of how to derive this, I'm going to do this in another class, but I would like to thank you for viewing, and remember to subscribe if you've not subscribed, and also like this video, share it around if it's been informative for you.